All right, well, we have a nice intimate group, so I'm expecting a lot of interaction from everybody. We'll take a lot of questions as we go along. Nick, remind me what time are we concluding?
We are at 45 minutes of Q&A.
Okay, all right. So if we don't have a robust set of questions from this group and online, we might finish a little bit early. We're a little bit on the small side. So I'm Rich Reifel. I'm a professor of finance practice in the Daniels Business School and a member of the leadership team for the Dean's Cabinet. In the context of what you're going to hear tonight, I'm one of the people that has been working on this new Master of Business and Technology program, and I'm joined by a couple of awesome individuals that I get a chance to work with on this. Ramesh Durvasula from Eli Lilly. He's a member of our advisory board for this program, and the academic director, Professor Mohammed Rahman. So thanks everyone for being here. Thanks to the folks online. I'm going to curate a few questions. We have kind of an interesting format. We're going to put Ramesh on the spot with some questions about how he sees technology and AI in his daily life at Lilly, where he's a senior executive on their tech team. And actually, not so coincidentally, one of the reasons he's here and has been working with us is because Mohammed and I have had the opportunity to work with Ramesh and his team on some executive ed and doing some training around AI. So it's been really cool to get to know Ramesh, as well as some of the use cases for AI and other sorts of technology at Lilly. So that'll be a great discussion. And then we'll also combine that with, how does that feed into our curriculum in this program, and how is this curriculum really going to help prospective students apply some of these concepts to work when you graduate and get out into the real world, as it were. So we'll get started. And so the first thing I want to ask is just tell us a little bit about your background, kind of your career journey to Lilly, and then if you could also comment. You're somewhat new to our advisory board, but we're excited to have you and thrilled that you're putting the time into this. But we obviously had some passion with you that you thought this was a good use of your time. So I'd like you to comment on that as well.
Absolutely. No, well, thank you for having me here. And glad you guys, glad we could get this organized. So I'll tell you a little bit, maybe I'll take 2 minutes to talk about my background. I did my, first of all, I wrote my first line of code. I was just thinking about this morning. I wrote my first line of code in 1981.
Was it on a punch card?
It was close. It was on a Commodore 32. So not far from a punch card.
Basic?
Yeah, yes, okay. yes. It had a GUI. It had a GUI. And going through undergrad and PhD, I got my undergrad and my PhD at the University of Virginia, did my undergrad in chemistry, got my PhD in biochemistry. While I was doing my dissertation research, half of my work was modeling and simulation of some molecules. The other half was going into the lab, making those molecules, testing them against the predicted behavior. And my R squared was like -5, I think. It was just pathetic. And so caused me to do some soul searching about what was wrong with my model that it so badly predicted what happened in the lab. Oddly, and yes, I admit that I'm a nerd, this lit a passion in me, a fire in my belly for computational chemistry. And so my work bled into computational chemistry. I found a software company that built software and sold it to the pharmaceutical industry of computational chemistry software. And so I called them as a grad student, said, I want to work for you. Worked at that company. It was like a 200-person company for about 6 years. Then I joined Bristol Myers Squibb in New Jersey for about a dozen years in the discovery IT organization. So computational chemistry bleeds very easily into R&D IT at a pharma. And then for the last almost 8 years now, I've been at Lilly, and now I lead the R&D IT organization at Lilly. So very happy to be here.
So talk a little bit about what, as you've seen the program, as we described it to you. Talk a little bit about, what excites you about that from the standpoint of somebody in industry that might hire a graduate from
no, of course. So, I mean, it's interesting. There's not an hour goes by without AI as a topic, obviously. But actually, not an hour goes by in my day without talking about how that technology bleeds into the business strategy. And where we struggle so much is when we have people who are strictly one-dimensional in their expertise unable to translate that strategy into each other's dimensions. So if we have IT people who don't understand chemistry, chemists who don't understand data scientists who don't understand business, economists and pharmacologists and salespeople and manufacturing people, all of them each in their own domains, experts, and perhaps world-class experts, but we're not able to have a conversation across because no one understands the other domain, turns into a limitation of our value. That really turns into a limitation for me. And so a large part of my role is to speak to the genomics researchers, speak to the X-ray crystallographers, speak to the clinical research coordinators, translate that into what the data scientists and the architects and the business analysts ought to be working on. And that translator role, that universal translator role from Star Trek, is something that I think everybody needs. And in my interpretation of this program, it's providing that universal translator that allows you to connect with any dimension, with every department, and then be able to navigate between them and thread the strategy to take advantage of every department's opportunities and potential. So that coordination effort is really what excites me about this program.
That's great. So you've touched on a number of things. I'm going to come back to a few of those, but this notion of being able to translate and talk to all parties is reminiscent of a great book I'd recommend to everybody called Range. Just having range across a lot of different disciplines. And as I've gotten to know some of your colleagues at Lilly, I'm amazed at the depth.
Is it by Epstein? The range book, is it by Epstein?
To be honest with you, I don't recall off the top of my head. Well, maybe we could put it in the chat. Somebody could look at that and put it in the chat.
Stick the Amazon link in there.
But what we saw is we were working with some of your colleagues. What was really impressive is the level of depth and breadth that they have, and it's obviously the reason why your company is so successful. So that's great. I'll make a quick editorial comment just to put you at ease. Everybody here is a nerd. So you don't even need to add, that's like redundant.
That's
good. Say like you're a nerd.
I feel comfortable then.
Yes, absolutely. We're all nerds of the feather. So Mohammed, if you could, you're kind of the mastermind, the father of this program, and maybe talk a little bit about what informed your thinking as you put it together, and what's the secret sauce in the curriculum that you think differentiates this program from others?
Yeah, sure. So, I guess as a business school professor, I have the privilege to talk to a lot of executives from different range of industries, right? And I've been doing this for many, many years. And I just love it because that's the way I think it informs me, keeps me also honest about what I'm teaching my students. And what we have learned, right, as I've observed, is that MBA was great. We were giving business education to all our students in the past 20, 30 years, right? But technology has become a central point of competitive advantage now for most companies, not just like the tech companies we think of, like Google or whatever, the digital natives everybody think of right away. No, it is now an essential element of strategy for whether you are in pharma, whether in manufacturing, whether you are doing whatever you're doing, right? In food, or trucking. So that kind of really told me, and I think the observation is also shared by industry. Industry is always ahead of us, is that we have this void of skills where people actually have a very good understanding of business as well as technology, where they actually can align technology with the business objectives to make sure the business is thriving. If you're just a great coder, or if you're just a great chemist, you're not going to necessarily create value for the company. You have to create value, and you also have to capture the value. That requires business thinking. But if you want to do value capture and value creation, just understanding business and thinking about margin and acquisition on just financial statements, not enough, because technology is central to now thinking about like how do we apply AI for a business like Lilly? How do we apply AI for a bank like Chase? Or whatever you have in your mind. And that's kind of where we thought about, okay, there's a big vacuum. And Purdue is a place where we can innovate. That's the beauty of Purdue, right? So, and we have very strong engineering. We have very strong computer science. We have very strong sort of quantitative business school. So we thought, you know what, we're going to take this from scratch and build a program that speaks to the future of what the economy needs, rather than trying to retrofit some of the courses. That's the reality of education sector, right? We have to people take certain courses, put them together, blend them together. That's what most of our competitors are doing. But we just had the opportunity with the relaunch of the business school to really think bold and come up with a new degree. And that's the opportunity I used to really build this program. But what I made sure is to talk to people like Ramesh and others and say, what do you guys need? Tell me, what do you think we should teach our students? That was one conversation. The other conversation was, once I put together the curriculum, go to the industry folks and say, what do you think of this curriculum? Right? So when we combine the two sides, that's when we came up with the design we have today. So that's kind of the genesis of this program.
You make a couple of great points. I think the traditional MBA hasn't really changed that much since post-war period when it became a thing to train engineers. So if you're in the Daniels School, you know that we have 5 strategic pillars. One of them is STEM equals business. So our Dean Bullard likes to say that technology has eaten business. So all as Mohammed said, all businesses are really tech businesses. So I'll pick on JP Morgan Chase because you mentioned them. I spent a number of years at JP Morgan Chase, and Jamie Dimon, the CEO, estimates that they have 800 use cases for AI. So you can imagine, as a leader of a line of business, you're challenged to say, I've got these digital native companies that are springing up that are trying to eat my lunch and disrupt my business or disintermediate me. You know, how am I going to respond to that with an incumbent business, with a very complicated tech stack, with a culture that's entrenched and all of that? But I need to take advantage of this technology, and that's not necessarily an easy thing to do unless you've been trained to do that. So that's what the curriculum is designed to do.
Absolutely.
So let's, without divulging any trade secrets, maybe you could give us an example or two of some of the AI use cases that you're seeing at Lilly or just in industry in general, because you speak to a lot of other people in pharma and whatnot.
Yeah. There's hundreds of opportunities. So I'll give you one example in discovery, one example in clinical, and we can even go down into commercial manufacturing if you want. In drug discovery, everybody is trying to understand how to leverage AI to do drug discovery better, faster, cheaper. Everyone wants to understand how do you leverage AI to design new molecules. And so it's easy to buy a piece of software that does the design of a molecule on your behalf. Where we find that's really interesting is you can't just buy the software and deploy it and think that it's going to be enough. And you can't have a company built on AI in chemistry software and presume that they can design a molecule better than a Lilly chemist. It turns out that the only way to figure this out is to hybridize the chemists of Lilly with the data science of Lilly in order to figure out where do we not just sprinkle the AI everywhere, and not to presume that one moment I'm doing chemistry and the other moment I'm doing AI, but to say, how are we baking AI into the workflow? How are we baking it into the mainline applications? How are we understanding what mission, what purpose, what outcome the scientist is seeking, and deploy the AI where it matters most, rather than deploying an entire new stack that we're going to force them to use all the applications they use today and this new AI thing over here as well. And that's where we baked it in. And we think that we have a more successful AI in chemistry program than a lot of our pharmaceutical peers and a lot of the biotech startups that are coming. We've run some head-to-head competition between them, actually, and we're finding that actually, I mean, okay, we're biased, but we're doing better, we think. But the reason we're doing better is that we understand the economics of it, we understand the science of it, we understand the data science of it, we understand the math, we understand the technology, and oh man, the procurement folks need to learn tech too, by the way, because the pricing of this, the deal making, the BD side of it, all of that. So AI in chemistry is much, much bigger than simply buying the software and using it. Similarly, in the clinical trial space, there's a huge, one of the biggest challenges we have, one of the longest poles in the tent. I always get that metaphor mixed, but the longest pole in the tent of clinical trials is actually enrolling enough participants to participate in your clinical trial. So patients need to sign up to participate in a trial. That could take 6 months, that could take 3 years. It depends on the disease, it depends on how you describe it, it depends on the investigators that are identifying patients in their own practice that may be qualified for joining a clinical trial. we're using a lot of AI to identify those patients and proactively say, if we put a clinical trial site in one location versus another, there's a higher probability that we're going to attract more participants in our clinical trial, accelerating that trial, which only allows us to finish the trial, get to the regulatory submission, and get the medicine into the hands of patients in order to address their significant unmet medical need. But the weaving in of clinical strategy, geography, culture, AI, understanding what patients need, the burden of patients, et cetera, all has to integrate in multiple domains in order to make the whole of using AI in pharma better. And so that's where I come back to this multidisciplinary approach is the only way to be successful. And those are just two examples, two use cases. I've got hundreds in my Rolodex already.
So I've heard your CEO say that the objective of the company is to reach more patients faster.
Yes.
So in all these facets, you're looking at
Every
technology
aspect.
as a way to
Absolutely.
shave a day here, a month here, a year
Absolutely.
here, and reach more patients.
There is two gears, if you will, though, that we're trying to understand how to use. One is take the existing process and use AI to make the existing process go faster. Okay, that's easy, and maybe we'll get 10% benefit out of it. But you guys have heard me say, what's the 10x way of doing it? And what we're trying to understand is how to reinvent the processes. So we go from yellow cabs in the taxi industry to Uber as an experience, because the Uber experience is one where Uber is not an AI company, are they? What are they actually? Are they a taxi company? Are they a transportation company? Are they a tech company? They're all of the above. And it's that integration of the disciplines and the reinventing of the purpose. Person A needs to get to location B without owning vehicle C. There's a excess demand for transportation of individuals without owning the vehicle. There's an excess supply of drivers with vehicles with nothing better to do, and marry the two with an economic approach and surge pricing and all that. That integration of multiple disciplines to create a new business model, we're trying to understand, what does the pharmaceutical industry look like? What's our Uber moment, if you will? That's what Lilly is going through that transformation.
I'm going to ask you a question in a moment, Mohammed, but I want to ask a follow-up of Ramesh first. So I have a son who's got doing a postdoc in organic synthesis.
Excellent.
And he says, AlphaFold's not going to replace me anytime soon.
This is true.
Okay. So this speaks to the way people deploy technology in a company. And
Yes.
I think a lot of people think, because the popular press tends to say this, that machines are going to replace humans tomorrow.
Yep.
Your job is at risk and whatnot. So maybe you could talk a little bit about how you're using technology specifically to augment humans as opposed to replace them, or move them to higher value tasks or something like that.
We say this all the time. The physician with AI will do better than the physician not using AI. The chemist that uses AI will do better than the chemist who refuses to use AI. So it's not that AI is replacing the chemist. AI is augmenting the speed, the capacity, the decision-making of the scientists. We need more scientists. We don't have enough scientists at Lilly, but we also need scientists who are leveraging AI to maximize the value, maximize the innovation that they're driving. We see that differentiation all the time, that those who adopt AI, embrace it, and reinvent the way they work are better, faster, more productive than the scientists or the clinicians or the sales and marketing who are just sort of shooting from the hip because they've been in the industry for 20 years. There's a clear differentiation there.
Cool. So, Mohammed, we've talked about
question in the back.
Oh, I'm sorry. Yes, sir.
First of all, thanks for posing the question. Because you come from a very deeply technical background, you did your PhD as well, and then you spent a lot of time in the pharmaceutical rising up different ranks. So you're very self-made and very hardworking on that perspective. I'm wondering, once you are at the level where you've seen the rise of generative AI or any kind of machine learning, everything boils down to the data. So, and you've seen how people from genomic data collect data. How do you see right now people collecting data, at least at Eli Lilly, and how has that changed based on the new AI models? How are you structuring the data? Because as good your data would be, as good your model could be.
Totally.
Also, nothing if they don't have good data, right?
Totally.
Garbage in, garbage out.
Let me just quickly restate the question for the online. So basically the question is, how are you collecting and structuring data to?
So what kind of data are you collecting? So because I'm assuming if it's only genomic data, it wouldn't be hard for you to just go out and buy something like a 23andMe, which is a little bit on the lower side right now. So I'm assuming that there will be something deeper than just finding some genomic data, some random people. So at least for clients or people that you're conducting your trials on, what kind of data do you collect? What kind of structure do you have changed? And has that changed from 10 years to now? Because technical background.
Yeah, no, for sure. For sure. The base answer here is you have to follow the science. 23andMe failed to follow the science. They followed the hype. And 23andMe made a basic scientific assumption, which was wrong, which is that all you need is the DNA of the patient. All you need is their DNA and maybe a little bit of self-annotation, like, yes, I'm this tall or this age or this whatever few disease indications, without connecting the omics to the medical record of the patient in order to understand the total longitudinal trajectory of their health. They just said, just give me your omics, do the cheek swab, and I'm done. That's all I need. And I'm going to come up with all kinds of insights and monetize the data to pharmaceutical companies. Ultimately, nothing has come of 23andMe. Right? GSK spent several $100 million to partner with 23andMe, and zero drugs have come out of that collaboration. And it's because the question should not have been, how can I monetize the data? The question should have been, what's the nature of the scientific question to answer? And then go get the data that's needed to collect in order to drive the answer to the scientific question. And so we are trying to understand how to merge omics with other data types that are related to a patient. It could be multi-omics, it could be digital health streaming data, it could be the medical record data, the imaging data, et cetera. But follow the scientific question is really the key for us. And then generate the high quality data set. One of the secret weapons of Lilly is that I think we have more statisticians on staff than any other pharma in the world, because we are extremely disciplined about the data and the quality of the calculations and the nature of the error bar that can be created. And so building a proper data set is absolutely required for good AI, but start with a proper scientific question. That's what we believe. Hope that answers the question. Happy to follow up.
Yeah, good luck.
Thank you.
Great. So Mohammed, as we're hearing about some of these use cases and the way technology is being incorporated into their business, no doubt there are a lot of cultural issues that arise, regulatory compliance, cultural change management issues. Talk a little bit about how the curriculum would inform a student to be able to address those issues on the job.
Yeah, so I mean, so if you take a student who are just fresh and hungry to be successful, right? What they're missing is the perspective on what does it look like to be working in an organization and perhaps negotiating with other parties in the organization about the very data that is owned by that organization, right? It could be Lilly owns its data, but then different groups own different kinds of data. How do we really bring together these things? Or think about Microsoft. You think about Teams as a product or Office 365 as a product, you want to change a ribbon, that change of that ribbon or that color you might think is harmless, but no, there are probably 20 other teams that are affected by that change. That thinking in sort of, how do I really think about a product in a business ecosystem is critical to be successful, right? Whatever that product is, it could be the genomics data, it could be whatever it is, you have to think about the environment. And that environment requires understanding people. Environment requires thinking about regulations, governance structures, right? So if we think about data, there are governance structures. There are companies that are self-regulating. There are data governance issues with the privacy HIPAA that's in healthcare. But if you think about other privacy issues in Europe or in California for a global company, these are different. So all of these should be in the minds of the employees who are gonna be starting their career. And if they wanna climb up the ladder, that's gonna be different for them versus somebody who just graduated and started the work without understanding these nuances and this thinking process. So in the curriculum, we're very intentional about it. So we make sure students take a class on negotiation because you have to know how to negotiate with others within the organization.
I fully agree.
Right? If you don't know how to negotiate, you don't know how to function.
100% right.
You have to learn how to work as a team. And the team is going to be diverse and it's going to have deadlines. It's not like I can just miss my homework and it's okay. No, that's not how corporate world works. You have to work under pressure and produce. You have to understand what governance means from regulatory perspective, from the corporate governance perspective, from sort of the antitrust perspective. Like, so all of these things, that mindset is what we really work on. And we make sure these are part of our core curriculum, right? We have a class in leadership because we expect these people who are just starting, right? So you might have a couple of years of work experience, but you're not at Ramesh's level. You don't know what does leadership mean yet. But
I don't either, but.
well, you're being humble. But that's kind of what we are trying to make sure the students get as part of their core curriculum.
Yep.
So one of the compliance issues that I imagine you deal with, and I've seen this with some of our other corporate partners, is where do I draw the line between letting other people have access to my data, letting my team access outside data to try to get the best data set to analyze. So I know we run into this with ChatGPT because that's an open system. So you got to be careful what you put in there. Maybe you could talk a little bit about, from a strategy standpoint, how do you decide what information are you going to share? Where are you going to partner? Where might data be a competitive advantage that you don't maybe want to partner with a Pfizer on some kind of drug? Those are some pretty, I think, value driving issues that I assume you're dealing with on a pretty regular basis.
It's funny. I made a joke at a conference the other day. I was in London. The joke fell flat. Do you guys know the Shania Twain song, "That Don't Impress Me Much"? I say that to the AI vendors all the time. So you got an algorithm that don't impress me much. The joke fell flat even in Las Vegas. I was in London. But the idea is that there's so many vendors out there who say, I have an algorithm, just give me your data and I'll give you back all kinds of drugs and opportunities. And we dig into the company, we try to understand, whom did you hire? Who's on your board of directors? Who's your chief data scientist? Put them in front of me and make them show me what they think is a good data scientist. What data do you already have? You think you have an algorithm. How did you design that algorithm? Who did you design that algorithm with? We dig into all of the technical, financial, strategic, leadership aspects of the company before I allow them to have a single kilobyte of Lilly data. And so we do have to be very, very sensitive because actually, as we were just talking about the omics stuff, better data leads to better models. So if someone says, I have a model, I just need your data. No, you don't have a model then. And there are so many people in the venture capital world and in the startup tech space who don't understand the science. And they think that just give me enough volume of data and I'll just come up with a great algorithm, a great model. They're going to fail, and I don't want to waste my time or their time, frankly, in building a partnership with them. So we don't share much of our data. We'd rather say, give me your model, I'll tell you if it worked or not, and then I'll pay you significantly. I'll pay you handsomely if I find a drug out of it. But if you presume that I need to give you my data, and I lose control of the data, that's a big deal. And it comes down to a lot of negotiating.
So I was talking to somebody yesterday that's working with a seed manufacturer, and they were saying the seed manufacturer was outsourcing their seed data to somebody that models, which seeds ought they to produce. So sort of similar plant science versus life science.
Absolutely.
So Mohammed, I want to ask you, we talked a little bit about strategy, and you talked about how you kind of started the curriculum really practically with a white sheet of paper. But specifically with strategy, I'm thinking back to when I got my MBA, there'd be all these great cases. There were a lot of cases that were like 30 years old, but were still being used and whatnot. They may still be used now, even if that was 30 years ago. But talk about the approach to designing a strategy course and sort of infusing the curriculum with strategic thinking that starts from a technological standpoint, or as I like to say, it's like tech forward or tech infused, as opposed to just taking a strategy course and saying, here, we're going to talk about Google today with this case study that I downloaded from a website.
Yeah, that's a great question. So in fact, that's why we have several classes to actually infuse that mindset, right? So one of the core curriculum classes we have is called Tech-Driven Business. And that starts with actually talking about business model first. What are the key elements of business models? Because I think many people, when you get a degree, you don't necessarily fully understand what is a business model, what are the key parts of the business model, and then think about, okay, unit cost within that business model, and how does technology change that, right? And that will change your sort of economics of what you can do in terms of strategy. So an example, like in terms of case studies, right? So we're talking about like a case like Webvan. which many of you probably don't know, but that is the first online grocery store that tried to do online delivery. The company failed in Bay Area. Because once you calculate the unit cost of that, what you will see is the logistics don't make sense. So it's not because the idea wasn't great. The idea was great. The logistics did not make sense. And so that's what the students need to understand, right? If you are going and trying to pitch an idea within Lilly, within Caterpillar, within whatever the company is, unit cost has to make sense for the business to make that change. So that's an example, right? So the other kind of cases we talk about is like, well, Dropbox, right? Or we talk about like other sort of, we're talking about classical cases, but we want people to think about, okay, what are these differences? We talk about Walmart, we talk about Amazon, very different business models, very different core competence, very different assets. How we expand is very different. And when we think about, and then another class we have is tech strategy. So this requires you to understand core strategy still, right? You still need to think about strategy, but you no longer are sort of thinking about having the asset that nobody else can buy, or having the patent that is your patent that works still in pharma, but it doesn't necessarily work in many industries, right? So now where do you get the sort of the benefit? Well, is the network effect. There is a reason why companies are paying billions of dollars for a bunch of users who are just on an app. Why? What does it mean for that strategy? So those are the things we really get into. So as you think about any kind of business, you could incorporate those ideas in analyzing what the future looks like.
And by the way, we have other sessions planned. So if you need additional information we can get you information about other sessions that'll be similar with other advisory board members if people in the audience here online care to get some more information on that. So we talked about this the other day in one of our sessions, how business historically has been focused on cost elimination and perhaps efficiency. And now in a more tech-enabled world, we're looking at value creation and customer experience. So I have the same question for both of you. How do you cost justify AI? Collecting data, storing data, analyzing data is very expensive. Getting some of this technology out into the field is very expensive, hardware, software maintenance, et cetera. So how do you approach that at Lilly? And then same question for you, Ramesh, from the standpoint of what skills are you going to be teaching in the classroom that, it's not just a simple present value. You're trying to, monetize a network and whatnot. It's a different sort of analysis. So,
yeah, the one of the challenges is that if we don't do this, it will be done to us. Right, it's a competitive environment and everybody is desperate for any way to innovate. And if they're going to innovate, it becomes a bit of this is the price of being in the business now, is to turn into, it's table stakes to become an AI company. That's sort of a basic layer. But there's also, look, there's in our world, in medicine and in biology, there's so much misunderstanding and lack of understanding of the nature of the disease that we need all this AI to actually bring more insight, draw more insight out of the disease, out of the clinical trials, out of the defects that we see in the manufacturing process, that we need to leverage this technology. And so we've always been a high-tech company, actually. Get this, in 1990, Lilly was the first company in the world, not a .org, not a defense company, not a university, to buy a Cray supercomputer. So we understood even back then, it's not like this is a new revelation now that, oh gosh, we need to use better compute and better AI and whatever. Back in 1990, Mr. Cray flew up to Indianapolis and handed a plaque to our CEO at the time saying, thank you for opening a market for me of private corporations buying supercomputers. And so this has been a journey that Lilly's been on. Every company is getting onto that says high tech is the price of staying competitive at this point.
interesting.
So, I guess, the way, so we think about really instilling this thinking with the students is like, think about the cost of ownership of a car. Like, if you think about the cost of a car, most people just think about buying that car. But car is not just buying that car. the car is a lot more expensive as you think about the gas, the insurance, the maintenance and all of that. And, and that's where you think about the trade-off of buying a new car versus an old car, right? So talking about, like, how do you really still relate to things 20 years later? That's the thinking process that we want students to get, right? And once we start there, we then start to think about AI, right? So what are the stacks, the technology stacks? Well, if you don't have the right kind of data in the whole pipeline, your end goal is not going to work well, right? So I think so we want to make sure we make the students actually understand the full stack very well and the cost of missing out at any level, and can use short circuit some paths and get to some level, but not doing something right? So those are the trade-offs we want people to think about, because today it's AI. In 20 years, in 10 years, all our graduates are going to deal with something different. I don't know what that different is, right? So last time, a general purpose technology we dealt with was the internet. At the time, we could not predict AI was going to be the next one. We knew, I mean, I've taken Lisp as a programming language 20 some years ago, but I couldn't predict this was going to be the thing today, right? But what I know is the thinking process we instill is going to be valid. And that's what I think is critical as we think about these decisions.
So this conversation reminded me of a tweet that I bookmarked a long time ago. So I'm going to show you this. It's a picture of somebody with a Jupyter notebook. All right, they have a picture of a Jupyter notebook, and the book is Intro to Machine Learning with Python. Okay, so it's a picture of a Jupyter notebook up on a page, and then a book, one of the O'Reilly books, Intro to Machine Learning with Python. This was from 2017, and the tweet says, "The new NBA." And you know who wrote this tweet? Can you guess who wrote this tweet? A Jupyter notebook, Python, the new NBA in 2017.
Was it linked to you, Marcus, from someone from Eli Lily?
No, although they're somewhat local, actually, in their roots. It was Mark Cuban. So think about this. Mark Cuban, the Mark Cuban, is learning Python and slinging code in a Jupyter notebook in order to figure out who to draft in the NBA in 2017. Long before Gen AI, long before LLMs, Mark Cuban, as the owner of the Mavericks, had to figure out how does he pick the best first draft for the Mavericks, and that is how he did it. And so if a founder, if a billionaire, if a CEO, including our CEO, is learning how to sling code in a Python a library under a Jupyter notebook in order to unlock some insight that's going to lead to a business decision, why wouldn't you want this master's program? That's what I see as the future.
I agree.
So,
that observation about your CEO is an interesting one, because one of the things I think about is just knowing enough as a leader to know if your team is telling you the truth about what can and can't be done, if they're being aggressive enough or too aggressive with technology. And that's difficult if you don't have that
baseline
range,
understanding, absolutely,
so.
that range, exactly.
Okay, the last question for both of you. What can go wrong? Maybe if you have an example.
How long do we have?
And you can anonymize it. And related to that, Mohammed, for you, how do we teach students about risk mitigation and unintended consequences in the curriculum?
Yeah. So it's the hard part about AI is model drift. Right. So if you don't understand model drift, go figure it out and understand it, be afraid of it, and then put all the airbags around your processes, around your data sets, and around your use and your deployment of a model to understand how to avoid model drift. These models are neural networks at the end of the day. They are not deterministic, right? They are probabilistic. They learn from every experience. They learn from every data point, and the weights within the models can change over time. Even if you don't feed it more data, the neural network is constantly evolving itself because it's a neural network like us. And so the risk of having a bad prediction where you actually don't even understand why it made a bad prediction, because neural nets are hard to understand why they make a recommendation, is really, really hard. I mean, of course, there's all kinds of bad in terms of movies that talk about dystopian dystopia in terms of privacy and robots and all that kind of stuff, okay?
2001.
Put all of that as, put all HAL and all that, exactly. Put all that aside, just understand in your world, in your future, how did the model get trained? How is the model behaving? How do you understand when the model is going outside of its performance parameters, where it's making a bad calculation, a bad prediction? And then think of all the business implications and the cost implications and the support models and the professionalism of watching the model to make sure it stays inside the range of high fidelity. That sounds really technical and annoying. Everybody in the world needs to understand this at the end of the day. And so that has huge business implications for us.
Yeah, well, like, so pedagogically, we started from the very first class. So like the class I teach, we allow all students to use generative AI. We want them to use it
You have
because
to
that's the only way you augment yourself and produce a lot more code in the given time to do all the assignments I want them to do. With one principle, you own all the outcomes. All the decisions that you're suggesting, you own the consequence of that.
Correct.
You cannot come and tell me ChatGPT gave me all of this, and that's why I did this. Now I lost points, or I don't make sense. ChatGPT is fault. No. You, as the human, own everything. And I think that's the principle we have from the beginning to the end of the program, right? So we definitely talk about risk and thinking about how do you think of all kinds of risk, right? Privacy, security, all of those things. But I think the bigger thing is internalizing the fact that no matter what technology we use, as a decision maker, you own the decision.
I love that.
And that's the principle.
Yeah. As a person and as a legal entity, as a corporation, this is true.
Absolutely.
This is
Yeah,
true.
Yeah. That reminds me when I was an investment banking analyst many years ago, and spreadsheets were a new thing. That's how old I am. You couldn't look at the spreadsheet and have a wrong answer. You couldn't say, well, there must be a mistake in the cell. I didn't pick it up. You had to say, like, does that answer make sense? And if it didn't seem to make sense, you'd go back and inspect back in it. So same kind of concept, but on steroids. So, well, thanks to our two speakers